Back force and back EMF. These are things, again, you should have picked up a little bit from year 12. In fact, last year, well, one of the exams we had quite a difficult question in year 12 on back force. But what we've got here basically is, let's start with back force. Back force is related to a generator. Back EMF is related to a motor. So we've got the usual north-south loop in a coil, or coil in a magnetic field. North to south is the direction of the field. If this is a generator, which it is because I just made it, then we're spinning a loop in a magnetic field. Now we've worked out all sorts of stuff to do with that now, and it's all been very much fun. Can't even speak properly these days. But anyway, we've been spinning this, we've worked out the voltages, that's all very nice. We know that when we spin this, we're going to get a voltage, and we can work out which way, because as we do the direction of motion, so I've got north to south, if it's spinning clockwise looking from this end here, then we can do the north-south, it's going up on that left hand side, that means the positives are going to go along there. That means we're going to get a voltage like that. So the current is going to flow this way. If we do the same thing on this loop, we'll get the same thing. The voltage will continue to flow that way. They're not going to oppose and cancel out, that's what I'm saying. So we get a voltage like that. All very nice. So if a current flows that way, this must be the positive, and that must be the negative. So our current goes like that. All very cool. So now our alternator is working nicely, and we're making a voltage. We could be sitting here with one of those ones you can't crank with a hand, or this could be a windmill generating it. Whatever, it doesn't matter. The whole point is, if we take these wires now and hook them up to a, well, we could just make it a lamp, couldn't we? A big lamp. It's all the lights in Auckland, if you like. What's going to happen is the current's going to flow. And as soon as that current flows, so which way does the current flow? It flows that way through the lamp. As soon as we get that current flowing, let's now have a think about what happens to the force. So now we do our north-south rule. North-south, current flowing. There's a force down on this left hand side and up on this right hand side. That's what I call the back force. We get this opposing force. So when the current flows, we get this opposing force. So the alternator is stiffer to turn. So V equals BLV from the Lorentz force law gives us a voltage. As soon as we sort of try and draw that voltage off, F equals BQV, again Lorentz force law, gives us F equals BIL, and we get a back force opposing it. So the alternator gets stiffer to turn the more current it's drawn. No free lunches, if you like. If it had actually worked the other way, then this would have gone out of control, wouldn't it? If the more current we drew, the more EMF we got, it would be an out of control situation, and the universe doesn't like that. So that's back force. So what's back EMF? Again, it's one of those things that happens, and it's sort of like nature saying, well, no matter what you do, I've always got this opposite-like effect going to happen. So again, we've got this coil. This time this is a motor, and with a motor, we'll make the current flow this way, and, well, which way should we make the motor flow? Well, we'll make the current flow this way. So in this case, you actually put a current in. So I'll put a plus there, minus there. So we put this current in, and we've got to ask, which way is the motor going to spin? Well, north to south, boom, boom. It's going to go down on this side and up on this side. Just use your right hand. Boom. That side down, that side up. All right, got to know your right hand rule for everything. All right. Right hand rule is always, for me, the main fingers are north to south. The thumb is the thing, the other bit of information you've got, and the palm is what you're looking for. That's the way I think about it. And in this case, what we're saying is this motor is going to spin clockwise, and at this stage we haven't considered what happens with the EMF. Now remember, EMF, E equals this Faraday's law, d flux dt. So when this flux changes, right, we are going to get an opposing electrical or EMF, electromotive force, in this coil. Now the point with back EMF is the voltage that we put into the coil to make the motor spin is going to be opposed by this voltage that gets produced in the coil because of the change in flux, and that's a back EMF. The only thing we've got to check is that going to be true? Is it going to be in that direction? And it certainly is. Can we check it just in at this point here? We've got to be able to do the rule and just think which ways the voltage going to get produced. Now in this case here, we've got our motor spinning that way, and so if I go north to south and I'm looking at this wire here, so north to south, the motor's going up, it's going to produce on this side. I'm trying to calculate the voltage in this loop here just using Lorentz force law. I shouldn't even do that, should I? But that will work it out. The change in flux will do it, or the Lorentz force law. So Lorentz force law, boom, back, up, sorry, the positives will end up going up this way. Now the positives going up that way mean that we've got a positive opposing this voltage. That was using Lorentz force law. We've already shown that it's equivalent to the change in flux. Change in flux can get a little bit tricky, and that's you'll see that if you look at that video as to why when the flux changes from positive to negative, the actual voltage doesn't change direction. But that's what happens, back EMF. We've got the movement of the motor, the current that produces that movement using F equals BIL, but as soon as that movement happens, we get a change in flux, and that change in flux is going to produce a voltage within this loop which opposes the voltage that we originally put in to cause the motor to turn. That's called back EMF.